Okay, so in this in the previous video we talked about the fixed parts of the robot. Now let's talk about the moving parts. Okay, so for the moving parts, basically we have the wheels, and we have 6 wheels, and the wheels are fairly complex. And actually, for the wheels, I didn't have access to a CAD file that looks just like the real wheels. I had to simulate it with primitive shapes. So it doesn't look exactly like the real robot, but I tried to make it as close as possible, and it was already fairly complex. Anyway, so for the wheels, technically I had to create a horizontal arm, right, that connects to the chassis. So it's here. It has the dimensions. How to calculate that? Well, I'm not gonna go through the math, but basically, if you know that the separation between the left and right wheels is the track, so you have to know how wide is the chassis, and then add a little bit more to that, and then also consider the width of the wheel, so that that horizontal arm has the right dimension, so that the wheel left and right are positioned in a way that we end up with this track, with this separation between them. I'm not going to explain the math, but I hope you get the point. So you have to do a lot of conversions to get the dimensions of this horizontal arm right. So then this horizontal arm, and then we connect it to the base link. So here's another fixed joint. So I promise you moving joints, but not yet. Another fixed joint, because this connects to the chassis. Then we have a vertical like link that goes down from the horizontal and will connect to the wheel that will touch. Then the wheel will touch the floor. Okay. So this vertical upright, again, if you know the how tall the robot is and the radius of the wheels and all that, so you need to calculate the dimensions of this box, so that the height of the position of the wheels matches the height of the chassis above the floor. So I think you know what I mean, hopefully, but I'm not going to go through the math here. And then you have the first moving joint. So basically, this vertical support can rotate. Okay, that's what will allow us to turn. It's gonna steer the robot. It's gonna rotate to allow us to steer the robot to rotate. So that's a revolute joint, meaning that it turns, it rotates, but unlike a continuous joint that can turn 360 without restriction, a revolute has limits. So here we define them, the lower and the upper limit. Check something. Yeah. So here are the lower and the upper limits. So this is, if I remember correctly, should be like 45 degrees in the negative direction, 45 degrees in the positive. This is radians, so I might be saying something wrong, but I think let's do it. Let's just do it. I don't want to say something wrong. Right, it's 2 degrees. Yeah, 45 degrees. Yeah, that's what I thought. So basically it can turn overall 90 degrees, but 45 degrees in one direction and 45 degrees in the other direction. So overall 90 degrees. And this is radians, right? You have to define it in radians. Don't worry about this. We're actually going to tune this later. This might not be the actual value. So this is a revolute joint. This will allow the wheel to turn. Finally, we define the wheel, and we have the dimensions of the wheel. You have to rotate it a little bit so that this cylinder faces in the correct direction. Otherwise, it will be facing in the wrong direction. Again, I'm not going to go through the math, but once you create your cylinder, you will see whether it's not oriented properly, so you can play with the rotations. It's oriented properly. And here, the radius of the cylinder comes and the length comes from the table, from the measurements. Is a black wheel. And then we connect the wheel to the vertical pole. Okay, so the vertical pole connects to the horizontal arm, is a revolute, and then the wheel connects to the vertical pole or arm, and is continuous because the wheel is a wheel. It has to turn 360 degrees, so there's no limit here. So that's it. That's it. This is just for one wheel, guys. So you see all of these things just for one wheel, and then when you create the other 5, many of these values will change because all of the joints will connect in different parts of the chassis, and they will be facing in different directions, etc. So you can see how complicated it gets, right? Like when once you start adding the other 5 wheels. But before we talk about the other 5 wheels, let's run this one. Okay, so this is 2, and here, well, here you get the wheel. And actually, again, this is ROS2. I'm not going to talk too much about it, but if you inspect the launch file that allows me to launch all of these visuals, I added a joint state publisher there. Actually, the ROS2 tutorial of R2D2 talks about this. So if you want to learn more about joint state publishers, and I will talk about it later in more detail when we do control. But right now, I'm just going to briefly mention that it's there, and it allows me to test the joint. So you see, this is the revolute joint. You see, it can turn 45 degrees in one direction, 45 degrees in the other. And then the drive joint, yeah, can turn 360 degrees. Okay, so, and there's a tree. There's also a tree. There's a tree. You can see the wheel has the horizontal arm, the vertical upright arm, and the wheel. They're all connected in a very nice tree. And then again, you can disconnect. You can turn off. Like I can hide the wheel. Oops! I can hide the wheel. I can hide the vertical arm. Yeah, pole. And I can hide the. It's not very obvious, but if I put it here, I can hide the horizontal arm. Okay. Anyways. There you go. Now, one wheel, a lot of work, a lot of code, crazy, right? You're probably already sweating about thinking about adding the next 5 wheels, but I'm going to show you a trick so that things get a lot easier in the next video.